Let's move into the second segment of the webinar. Please explain what are the challenges associated when doing a project or research with products in mind, and also how we can manage it.
Right. So the first half, we have considered what are the important points we need to consider. The second half, we actually will get the answers to what are the challenges, what are the issues we have. In the first one, we actually discussed the issues such as factor conditions, gas, petrol, bhumita, all these kind of factors. These are called factors of production. So electricity problem, all these things are these are not actually business problems. These are factor problems. But when it goes to future research work, there are other issues that are more severe than just energy or other things. So what are the key challenges? What are the challenges that you face as a researcher? Now, if you look at the problems in Sri Lanka, such as income problem, petroleum, energy problem, all these things are not only inherent for researchers. These are felt by the other people as well. Industries, everyone, tourists, even the government has started experiencing some of the problems. So these are not inherent to researchers, but we are looking at what are the challenges specific for the researcher. What are the challenges specific for the research community, postgraduate researchers, industrial researchers? So this research community is having certain problems currently, particularly in terms of engineering research. One of the things is sustainability. This sustainability that I'm talking about here is not the it's not that one. This is to make sure that when your innovation goes into a product, let's say you do some kind of pitching to find some sort of a manufacturing partner, maybe a friend, maybe someone who knows, maybe or someone who is out from the university. You found an industrial partner to undertake your research work into a commercialization. You can't, it's not advisable for you to just leave it and see whether the company can do something for the first few months, but then afterwards, so you have a responsibility to ensure that the product moves in the market in the longer run. I have taken this very familiar and very popular example of Nokia. So this Nokia has been taken as one of those historic examples where they have been, so Nokia has been taken as one of the most successful products, brands, and these innovations that actually failed halfway through because they didn't have the sustainability. They didn't sustain their business for a very long time. So when you actually introduce your product, it can be just as good as Nokia. So Nokia was those days. I can actually give a sort of a quick example for this one. I have this. So this, by the time that Nokia was introduced in Finland, at the height of Nokia, the company was attracting 56% of Finland's GDP. It's a Finnish product from Finland. So it attracted close to 55 to 56% of the national GDP of the country. Let's assume that one company is earning half of the income of the country. So their innovations were that strong. But Nokia doesn't exist as a brand anymore. It's been just scavenged by someone because it was dead for a while. So we need to ensure that our innovations, when they go into the market, it needs to sustain. Sustainability comes because of divergence. That means you can't have the same product for very long time. So you need to have divergence in your product. So divergence means your innovation has to change according to the social requirements. That is what the biggest problem Nokia had. Evolution of the product and technology. So for your innovation, let's assume you invented something energy efficient product for Sri Lankan houses, because the electricity prices are going up. So energy efficient solutions are very important. So you are trying to figure out energy efficient technology for Sri Lankan houses. It can be energy efficient communication system, energy efficient heating systems, energy efficient houses. So there will be more thermal efficiency. So the energy efficient solutions are very attractive. So we'll find out, we'll focus on that. When it is energy efficient solutions, according to the local and social requirements, these have to change in the future. As an example, those days, energy efficient solutions were mostly firewood. Let's take heating problems, firewood. So they had various energy efficient things with firewood. But then the electricity came. In the electricity, when you use electricity, let's say electricity is more energy and efficient and it's environmental friendly as well. So there is an improvement. There are various solutions. There are microwave ovens, there are infrared heaters, there are coil heaters, resistive heaters, induction heaters. All these are heating systems, electrical. But there is a divergence of technological improvement because the technology changes with the time. So when you introduce your technology into a market product, it has to change according to the environment. Now, there is a huge, let's say after some time, Sri Lankan houses run on solar electricity. So solar electricity is running on DC. If it is AC, you need to do an inverter. You need to add an inverter and convert it back. So whether there is a DC based heating system, I don't know because I'm not an expert. Let's assume that there are solar based heating solutions, let's say water heaters. All these energy efficient technologies can be evolved from your innovation, and you have already created a research community who can look after these changes, because you will do the research and after your research is over, you will either go to another country or you will stay in Sri Lanka, find a job. So who is looking after your innovation? Who is doing the research and further developments of your work? So these are the problems you need to handle when the technology moves forward. There has to be continuous research. There has to be a team who is doing that. And there has to be continuous supply of resources for the R&D work in the industry. Otherwise, you will also have the same problem Nokia had, and you won't be able to grow your business up to the level Nokia grew. So sustainability is something to do with the product life cycle planning. Product life cycle means you need to understand what's happening outside Sri Lanka. For you to understand what is happening outside Sri Lanka, there has to be more than a literature survey, which is something I'm going to explain. Risk management is something where you will assess the risks that your innovation will face. There has to be a mechanism that you can forecast the risks that you will have, and you need to take the measures to handle those risks in your innovation that will have a significant impact in the future. So I'll actually list down a few risks that you will have. You can take notes if you like. These are interesting things. Possibly these already know these things. Raw materials. There will be raw material issues. Sri Lanka is struggling in terms of importing essential items. Plastic items, you have seen there are taxes imposed on 359 items. So raw material imports will be a question. You will have a risk if your innovation is dependent on raw material imports. So be careful, and you can do the innovations based on minimal dependence of raw materials and imports. Raw materials. And the other thing, international research is a risk for you, because other countries have better research facilities with extremely high technologies. You may also try to develop something which is reasonably technological for Sri Lanka, but there is a competition. International competition will come and try to kick you off. International products will come. Your products, when go to international markets, they will compete with existing technologies. International research and products will be a threat. At any point, it can come and kick you off from the market. The other one, energy is a crisis. If your product is dependent extremely on energy, you'll have a problem. Energy. But if your solution is how to tackle the energy problem, then you have a market. So these are like basic issues. There is another issue, labor. Currently, labor cost is very high. If it is semi-skilled person, so if your innovation goes into a production which is labor intensive, that's not going to be a very good innovation. But if your innovation is now, there is a course in University of Moratuwa called integrated design. So in that one, there are designs that are suitable for manufacturing, easy to assemble, or you can automate the assembly automation. So automation is something that you can think of, which will eliminate the dependence on labor. That will create cost benefits, efficiency, and also independence from labor issues. So your innovation should fit into the risks that you have seen. These are the challenges. Labor shortage, energy crisis, electricity problems, fuel problems, labor crisis, raw materials, distribution. There are distribution channels that are having these issues. Sometimes there may be a service product that if it is a computer-based service, let's say an algorithm or a website or something, you can actually use cloud-based services, cloud. So you don't have to actually pay for the servers, you just subscribe into a free cloud. Or you can sometimes use processor, cloud-based processing, not storage. This is processing power that you can actually borrow from cloud. So you don't have to invest in infrastructure, CPU, because you have thought there is an issue in terms of now. You may have seen the prices of laptops. i5 is now closer to 200,000. i7 is closer to 300 and 400,000. i7 is like 500,000. The prices are like skyrocketed. But why do we buy all these things? If your research is based only on the processing power, then you have an option of using cloud-based processing. That means you have seen the risk and you have designed your innovation in such a way that the risk is handled properly. So there are similar types of risks. I'm not going to go into all the risk types. You can look at the testile factors and understand these risks. So there was a question finally, how do we create a product roadmap? What is the roadmap? What is a roadmap and how do we create a roadmap for our product? So I need you to speak now. Can someone tell me what do we need a map for? අපි සිතියමක් පාවිච්චි කරන්නේ මොකටද? Can someone tell me why do we use a map? Why do we use a map? Yes.
To find where we want to go.
To find where we want to go. Okay. Any other answers? This is getting interested now. Why do we use a map? To find out where we want to go.
Find the best path to go for a destination.
Find the best path. Okay, that's interesting. Find the best path. Find the best path. Let me find the path. What are the other reasons you use a map? Because for research, it's pretty much the same. Using the product roadmap, you can figure out exactly the same expectation that you have from the roadmaps. What are the other things? Why do we use a map? So actually we can, since you have given some interesting answers, find where we want to go. That's now. Let me ask another question. Now, do we look at the map to find out where we want to actually go? Sometimes yes. Let's say if there is a waterfall, we need to locate that place. If there is a waterfall, we locate that place. Yes, in some cases we use maps to find out where we want to go. But in most cases, let's say you go to Kataragama, Anuradhapura, any sort of a place, you don't use the map to find the destination that you need to go, because you already know where you want to go. But sometimes in the maps, you find out where the location is. In the same way, for products, the product roadmap is rarely used to figure out what is your destination. Sometimes some people can do it, but it is very rarely used to figure out what is your destination. Just like the normal trips, you already have decided where you want to go. It can be pilgrimage, trip Kataragama, Api Yamu, Riverstone. So you already have decided where you want to go because you have figured it out outside. But you use the map mostly to figure out what is the best path. Sometimes you can use exactly in the same way. You can use a product roadmap to decide what the destination is, but the product roadmap is very less helpful to figure out where you want to go. Where you want to go is something that you need to decide. Just like the normal trips that we go, picnics, we first decide where we want to go and then find out what is the best path. Now in this image, you can see there are best paths because they are halfway through you can find a park, halfway through there is a cafeteria, you can rest a little bit, then you go to a final destination. And sometimes you avoid traffic. In the same way, in the product roadmap, what we do in the product roadmap, we figure out exactly what do we want to achieve from this thing, from your innovation. What is the best mechanism? What is the best path that you can follow to achieve that expectation? I mentioned to you some of the key expectations that engineering researchers will have, such as by 2025, I want to introduce a very sustainable energy source, energy mechanism, solar-based domestic mechanism. Or you can say within 3 years, I want to develop entirely artificial intelligence-based sensor system. Or there is something that we are doing in University of Moderator. If we have a target like by 2025, we want to develop a fully automated digital patient diagnostic mechanism. Currently now being doing with paper. Sri Lanka is struggling with paper for some reason. So this is computer-based digital patient diagnostic mechanism, which is less dependent on paper. It is it can be computer-based. So there are targets. Sometimes you can say, I want to see all the houses become energy independent by 2030. It's okay for you to have very long targets, but that's the destination you have already designed. You have thought this is the destination. That is what we call the product vision. So the product vision is all about your final expectation. I want to achieve this thing through my innovation. Mission or the strategy means how do you achieve this thing? Is it through private businesses? Is it through the collaboration of the domestic people, households? Is it through the collaboration of motor vehicle users? Is it through the integration of entire world businesses? So there is a mission. That means the path that you can follow. Although you are doing the research, you can actually decide what is the path that you follow. So you can say, I am achieving this thing through the collaboration of every household in Sri Lanka. That's a big target, but that's a strategy you have. That's a strategy you have. So there are certain innovations that people have very strong strategies. That means the innovation is designed so every person in Sri Lanka is getting the benefit. So that's a mission. As I mentioned, priorities and omissions are there. That means there are things that you prioritize, there are certain things you remove, such as dependency on various external imports, and also sometimes you can say, I am going to do all the things by local raw materials. Then there was something called Siriwardhana. Now that's the priority. Now India has a very strong priority. They are called Make India, Buy India. That's the Indian priority. So India has a priority for their innovations. Any research, any innovation, any product commercialization has to have 80% of local raw materials. There are certain 70% or 80% of local supplies should be there. Value addition should be local. So these are priorities for innovations. So you look at the priorities, then you find out the divergence. That means what are the various varieties that your innovation can go into. Let's say if it is a smart sensor, if it is a gas sensor, whether I can use the gas sensor to detect LP gas, whether the gas sensor can be modified to identify carbon monoxide. Now you remember there was a carbon monoxide poisoning in somewhere in Nuwara. This couple died because they kept the barbecue charcoal inside the building. Now let's assume that building was occupied with a carbon monoxide sensor. It could have saved 2 lives. So these toxic sensors can be of help at any time. It can be domestic, can be commercial buildings, automobiles, factories, military. So you can actually decide whether your innovation can fit into any industry. It can be gas detectors. So your technology should have divergence capability. Otherwise, it will fit into only a narrow bandwidth. So that's an innovation you can think in the product roadmap. I will show how a roadmap looks like. Convergence means whether you can combine two innovations together and make a new innovation. As an example, there was I think Slintech developed a sensor that identifies the carbon dioxide. I think one of you can explain carbon dioxide sensor into the mask, face mask. So it's an innovation. It combined two things: face mask, carbon dioxide sensor, carbon monoxide or something. So it combines these two and say, okay, your mask is ready to be replaced, or you are having breathing problems, something like that. So these are combining. That is called convergence. Convergence කියන්නේ එකට එනවා. Divergence කියන්නේ එක එකට වෙන වෙනවට යනවා. So convergence is also innovation. Divergence is also innovation. These are specific things you can do into in the product roadmap. You can draw these things in the product roadmap and planning. And the value of prior art. I mentioned I'm going to come into a sort of a discussion about prior art. So this is how a product roadmap looks like. So you have the year, that means time that you start, the name of the critical milestone you want to achieve, just like a product 1, product 2, change in the product version, can be any change in your product. These are not just innovations, these are innovation plus product conversions. Then you have a goal. Now in this example, you can say attractive user interface plus 100,000, 10,000 users in the first month. So these are like product targets. Improvement of the design, changes to the product variations. So you can add various product changes and features in the product goal. There will be various features that you can actually have in that particular change. So based on each time, you can introduce various products. Let's assume there is a fast moving consumer good, such as food items or any cosmetics, general rations. Now I have highlighted April 1st and October 1st. Now these are milestones in the timeline. April 1st is where you get, although it's more April is a place where everyone gets ready for New Year. So although you are a researcher, you can think whether the product has a specific way that it can be offered in this New Year season, because it's a specific point in time where special events are coming. October 1st, you can start Christmas related product developments. If it is completely suitable for this festival season, you can actually introduce various things closer to Christmas, closer to New Year. Or sometimes in engineering things, you can actually introduce various things suitable for an engineering exhibition. Exhibition-oriented innovations can be done. So there are milestones you can achieve throughout the year, or throughout 5 years. You can have various milestones that you have planned to achieve. So there are names, goals, and features of your innovation that will have special outcomes according to that time. So the product roadmap will also have who is involved, people and tasks who are involved in that. What are the now this one is a particular mobile based application. So you can have what are the technological features and commercial features you can add, and also what is in the marketing team. You can add various other categories as well. What are the things you want to change in each period, and what are the tasks that you do. This is the simple product roadmap. So you have already gone through the innovation roadmap, which is the innovation technology readiness levels. But eventually you are going into product roadmaps. Let's see whether we can look into the questions. So shall we come to the questions at the end?
Okay, sure.
Yeah, so we'll come to the questions. So this is the product roadmap. So you draw the map and locate various milestones that you want to achieve in each particular time. So I mentioned there was a question about whether we miss something by doing only the literature survey. Now, literature survey can be done for your research because it gives what are the published activities that is available. Now, interesting point is literature surveys give what researchers want others to know. Literature survey gives an idea on what researchers want everyone to know, but the prior art search gives what they don't want others to know. So although you can see that, although you think that the patent is a sort of a disclosure, it actually gives an idea what people don't want you to see. So the researchers want certain things, so they do the publications. So you find out the research gap, but there are certain activities, pure research activities, where people protect certain things, such as patents, white papers, and specific organizational case studies, and also various other intermediate activities such as blanket papers, innovation-based blanket papers, and also there are applications that they have made for various copyright protections, for various commercial activities that are being taken. And also in the prior art searches, you are not restricted to patents and publications. You can go into various commercial papers as well. Commercial papers, called white papers. White papers are like special cases behind businesses. So in the prior art search, apart from the literature survey, you will understand what are the global locations where these activities are being taken place. Where in the world that these innovations are taking place, so you can understand what are the countries who are interested in these. As I mentioned, in the product life cycle, there are certain countries where hot activities are happening, hot spots for the research. So in the prior art search, you can find out the world map of research activities related to your topic. If it is energy solutions, there are certain countries who are interested. So then you can figure out what are the research companies and organizations you have to be careful about. So it gives the geographical maps of research activities around the world, which is very important, and also correlations between various disciplines. Now in this first diagram, this is the US Patents Office prior art map. It's a map which gives certain correlations about robotic system, as I can see. So you can see there are correlations between various topics. When the correlations are very high in terms of scientific literature, that means two keywords are appearing together. So then you can figure out what are the other areas where your innovation. Let's assume you are doing vision. Now there is vision recognition in the word vision recognition. Now, vision recognition is related to self-localization, distance sensor. It can go into cartography, motion sensors, voice recognition, walking controls. All these engineering solutions are connected. Then you can figure out what are the additional areas that the world is looking at. Not only you, the world is looking at various other things. Intelligence control, artificial intelligence, robotics. All these other areas are subjects where researchers are working. So you can figure out the dimensions, horizons where your idea can go. Also, it gives heat maps. That means what are the areas where highest research activities have been taken. Now, these red spots are like hot spots. Heat maps give you an idea about what are the hot areas where people are looking at. AI, artificial intelligence, is a hot area where people are looking at. Cryptographic algorithms. Cryptographic algorithms means blockchain based cryptographic algorithms, very interesting area. Machine learning, interesting. A lot of people are studying machine learning. IoT, Internet of Things. How can we connect all these things together and do something? All these things are hot topics. When you know the hot topics, there was a hot topic, it's not hot anymore. Cloud computing, that was hot topic in the past. Clouds. Now there are new hot topics coming up. NFT is a hot topic. So these things become interesting areas for researchers. You can find out these hot topics, correlations, world maps only through prior art search. So if you are particularly researching to introduce your innovation into a commercial outcome, a prior art search is a must because it gives the commercial climate and the environment about what is going on outside the world. So that's the benefit, and also it gives the idea of applications. When you look at this prior art work and the related organizations, the prior art search gives you who is doing that, which company, whether it's BMW. So some of the most highly innovative companies are Denso, which is a part of Toyota Corporation, and Huawei, Samsung. So these are the companies who are interested. So when you look at the global collaborations and global application, you can see what are these companies doing and what are their innovations. You will understand where to innovate and where to change your products. So selecting the starting point is the last sort of thing. So it's selecting starting. Where do we start now? In the picture, you can see there is an energy crisis in Sri Lanka. In the energy crisis, we have been forced to find out various alternative solutions. So it's a good starting point for the country as well. So selecting the starting point is assess your current technical position. Technology readiness level, you will have a particular point because you studied it in the last session. Product life cycle position, I mentioned, where do you stand in terms of global product life cycle? And you do a prior art search. In the prior art, it includes the literature survey plus other commercial activities, patents and commercial papers. So you establish where your innovation is, whether it's highly challenged or whether you are in a very good position. Then you can establish the industrial climate and the trend using the mechanisms I mentioned, such as this is industrial climate. You can study in the industrial climate using the Porter's diamond model, and also the test yield factors can be used. Then you can do a resource audit. That means what are the resources you have in hand. As an example, in the picture itself, there is a resource shortage that you have. So you can assess what are the resources you have, and you can work from the resources that you have in hand. Because when you go for industrial collaborations also, they will also struggle in terms of various resources. So what are the resources you have, and you can design your products, innovation and the product to match the resource availability they have. If it is labor intensive, just try to automate. Simple example. Then I mentioned undertake a risk assessment. What are the risks that you have? So you need to map all the risks you have. Credit risk, it's not technological. Credit risks, energy risk, the current business volatility. A lot of companies have been shut down. A lot of companies don't like to collaborate with the universities because they don't know whether their income is stable. US dollar currency problem. All these risks have to be assessed. Then for each risk, you can actually figure out a way or an alternative mechanism to handle that risk. Simple example, what are the, now in the morning I mentioned to some of my colleagues at Race Lab, if there is an electricity outage, if there is a power cut, I will have to share my presentation to someone else. So they can actually share the presentation, so we are not affected by the electricity problem. So these are like simple measures for current risks. So you can actually figure out whether your innovation can fit into these risky situations. Pitch and collaborate early enough. That means once you prepare your resource audit, risk assessment, climate evaluation, and your technical position, you can go into an industry and tell them that, okay, my product is in the minimum viable stage, MVP. Now we are ready to do the industrial trials, and these are the things that we need to test and see whether we can manufacture it industrially or whether we can launch it in a commercial scale. So pitch and collaborate early enough means if you collaborate early, there are benefits because sometimes you can do the research activities at their facilities. Recently, you may have seen you didn't have access to the lab facilities. As students, we have been struggling. All the university system is struggling in terms of accessing lab facilities because the labs are closed, lab assistants are not there. So if you have collaborated early, you can actually go and work with the industry because industries are mostly open. So that's why you need to collaborate early enough with industries, work with them, and sometimes you can work in the actual industrial environments, which is a very good thing for industrial engineering research. That's the starting point. So as I mentioned, risk assessment as a researcher. Now you can see in the picture the film cameras. All these film cameras are actually gone, which has been replaced with the digital cameras. So that's a sort of a replacement how innovations happen. Timing in the technology readiness level, you need to figure out where you are in the technology. Destructive innovations such as this, destructive means the new innovation destroys the previous one, such as the digital cameras completely removes, destroys the film camera market. Factor risk I mentioned, that means labor, technology, machinery, all these finances, big issue. Financial risk is a factor risk, which is happening for most of the students. So there are various ways you can find finances, ask for projects, various finances are there. So financing risk is there. Red ocean risk is the competition, industrial competition. A lot of companies are there who compete with you. So you need to address the competition and see whether your innovation is unique enough so it can face the competition very successfully. So uniqueness is something that eliminates the red ocean. Red ocean කියලා කියන්නේ blood bath. මේ කාම ගහ ගන්නවා. So if your product is innovative enough, unique, you can handle that risk as well. And also business model risk. That means if you have the wrong business model, you will have a big issue. As an example, ink pens. It's very rare that a lot of people use ink pens. I have seen some of my friends using ink pens. Ink pen has a business model where you have to buy pen and ink. So two products, complicated. People like less complication. That's why they use pens like this, which is easy to use. The business model can be designed so it's easy for people to use. So all these design related things can be as kind of a risk assessment for you. So you minimize all these risks through your innovation, and then as a researcher, you will understand that your innovation is fitting the market requirements that you have. So that's the That's the complication of doing research, particularly targeting market conditions. So you may have understood what are the, in the second session we went through challenges. Why do we use a product roadmap? How does it look like? What are the elements of a product roadmap? And why do we use a prior art survey? Because it shows a lot of other global industrial elements that you don't see in the literature survey. Where to start? So there is a 6-point evaluation, 6 points that you need to consider, including a risk assessment, particularly to assess what are the risks that you have. And then once you have it, you carry out the research, get the findings, and as I mentioned, you set up a collaboration with the business. That's the point where I can go. So you can actually open the discussion for questions.